Hello dear students, welcome to That's It YouTube channel. I am Kasu sir. Like in every session on every Monday, I am discussing some important topics. Today I came forward with one of the most useful topic for JEE NEET known as the projection formula. That means based on these or using these formulae, you're going to learn how to interpret or project a three-dimensional molecule on a 2D paper. And the application of this particular topic is widely seen in stereoisomerism, whether that is the configuration of the carbon atom, that means arrangement of the groups around the carbon atom, or the stereochemical aspect of a chemical reaction, right? The stereochemistry of a reaction. These two are the main important factors or features related to organic chemistry, right? So in order to learn these concepts, we need to have a grip first of all over what you call the projection formula. That means you're going to apply these formulae on to the reactions or configurations. There are usually four projection formulae which are being studied. Alright. The first one is called the Fischer projection. Second, we are going to learn here wedge. Third is Newman. And fourth is Sohars. So these four projection formulae we are going to learn in this session. Right? The idea behind writing the projection formulae is the arrangement of the groups around the carbon atom which is saturated, hence known as sp3 hybridized in a tetrahedral manner. So if the carbon atom is saturated, if it has no pi bond at all, the groups are arranged in a tetrahedral manner. And you know that tetrahedral is a three-dimensional shape. You can see it on your screen, isn't it? It's a 3D structure. So this 3D has to be interpreted on your paper, which is 2D. Now, when you have to do that, you need to be thorough in this projection formula. That means when you're drawing a structure on your paper, I, who is looking at that structure, must understand where and how the groups are actually present in a 3D space. So that is the purpose of projection formula. So whenever a structure is printed on a textbook, then we should be in a position to see that and understand how actually the groups are present. So that is the whole idea of this projection formula. Alright. So you can see that the angle over here is 109 degree 28 minutes. You take any angle, alright. So it's a tetrahedral projection, out of which two of the hydrogen atom in case of methane are going in one direction, whereas the two other opposite. So this is the main point involved over here. Now, when I explain what you call each projection, probably you'll be in a position to identify how this exactly looks like. Now you can see on your screen, the first one is called as Fischer projection. Whenever you write a projection formula, it always matters on which side the observer is actually present. Observer is you who is looking at that particular molecule. You see, this is the eye of the observer. I am looking from here. You could see that if this carbon atom is sp3 hybridized and tetrahedral in geometry, I have two groups, namely let's say A and B are aligned in one direction, whereas these two, I'll label them as C and D, are aligned opposite. Alright, so when I am viewing in this dimension or direction, you can see that A and B are towards the observer, C and D are away. Alright, so these two are towards the observer, and these two, alright, these two which I am marking here are away. Now the same has to be, you can see, interpreted when slightly tilted. When you tilt this molecule, towards yourself. You can see this is A, this is B, C and D, isn't it? Now the same thing can be written using the crisscross formula, wherein you will write A, B, C, D, isn't it? So remember the groups that are present on horizontal line. The groups that are present, groups on horizontal line are always what? Towards. A and B are towards the observer. And groups on vertical line, these two are always away from the observer. So this is the whole idea of writing the Fisher projection. You can write the Fisher projection with more than one such sentence also. AB, and let's say C and D groups that are present over here. You can put anything instead. Hydrogen, bromine, COOH, CS3, CS3, whatever. If you want me to take particularly any sort of groups, I'll take some groups here so that you can understand better, right? So let me take tartaric acid, alright? I'm taking here a compound which is very important for dentistry called as tartaric acid. So what does this mean? You can see there are two such carbon atoms that are present here, junctions. Alright, I'm putting that with asterisk. Okay. Now you can see that these two carbon atoms are having hydrogen, OH, COOH, and this whole group. Hydrogen and OH, if you take any of the each junction, are present towards us. COOH on this entire tail is present away. That's all. And it's not only that, you can see two OH are also eclipsing with each other. That means I am seeing from your perspective, you can see there is OH this side. On one junction, there is OH also present at the same side at the other junction. So if you are looking from your side, you will be able to see only one OH. Same is the case with two hydrogen atom also COOH. So what does it mean? Here, I'll write it here, 2 OH, 2 H and 2 COOH completely overlap. In our terminology, we write it as eclipse. It's nothing but overlapping. So this is how you're going to write the Fisher projection, which is a bit simpler. In fact, you will just use here only the crisscross formula. And let's move on to the wedge projection. This is somewhat similar to what you call the Fisher projection. You can see you're standing right here. This is your right side and this is your left side. So when you're looking from that perspective, you're focusing on this carbon atom. Hydrogen is on the left side, alright. Bromine is on the right. You can see the alignment. Okay, you're looking from here. You see the interpretation. What does it mean? This which is on the left side is away from the observer. This which is on the right side, alright, right side is towards the observer. You can see it over screen, alright. You can see this image, you will understand better. If you want to understand this again, you are tilting it. Left, right, hydrogen on the left, right. So you can see H and Br and these two groups are also present. One is methyl, the other is ethyl. So this is one way of interpreting the molecule known as wedge, which is little simple compared to the wedge one. The next one is called Newman projection. Same similar type of arrangement you can see. This is mainly used for the compounds which are having two such intersections or junctions. You can see over here that these are the two junctions which are present. Okay, so these are the two junctions. So you can see this has chlorine, hydrogen. Alright, so hydrogen is present on the left, chlorine on the right, and methyl. Okay, when you look in that perspective, methyl looks to be pointing towards you, isn't it? You can see it is pointing towards you. So left, this has hydrogen, right has chlorine, and methyl is towards you. because you are present here. You are present here. You are looking from here in this dimension. Left, right, towards you. Same is the case with this. You can see. Alright. Same is the case. Hydrogen is on the right side. Bromine on the left, you can see bromine that side. So always dotted means away from the observer. Dotted always means away. A line, which is also called as wedge, is towards. Dotted is always away and thick is towards. So you are interpreting this molecule like this, so that you are able to see only the groups that are present on one such intersection. You can see over here you are able to see only this as a main frame, hydrogen, chlorine and methyl as I said, and then I am erasing this. Then you can see bromine which is present on the left, it is overlapping with the hydrogen. You can see hydrogen is also away, right, away and left side. So these two are eclipsing, and CH3 and OH. One is downside, the other is upside when you are observing from there. So this is what you call as Newman projection. Important one, frequently seen in what you call conformational isomerism, that is in hydrocarbons, alkanes as well as the alkyl halides. Now you see the next one is called Saha's projection. You take the similar molecule which I have drawn in the past. You can see the arrangement of the groups. Same thing, Newman I have drawn here. This is the intersection that we are talking about. You can see it has one group. Okay, top left, it is partially aligned towards left. They are not exactly present at the center because it's a three-dimensional tetrahedral geometry. You can see OH, which is on the left, is always away. So it can also be interpreted with the dotted lines. And this is on the right. This ethyl group is on the right. This is top left. Methyl group is on the top left actually, though you interpret it in the middle. So this is always interpreted with the thick line previously. Okay, so this is the arrangement of the first carbon. Look at the second junction. Bottom right, slightly to the right side only. Chlorine. Though they appear exactly aligned, they are not. Okay, bottom right. Then bromine, which is on the right side, is represented with thick line. That means it is always towards. This left side group is always away. So this is the alignment on a Saha's projection. So whenever you interpreted the groups on a particular projection, you need to understand first where the groups are present. Then only you are able to what you call draw the structure in a proper manner. For example, you see, I'll take a molecule, right? Suppose I have same thing which I wrote before. Tartaric acid I will take. If I have to interpret one of the Saha's projection formula for this, see how would I write? COOH, COOH, HOH, and HOH. That's all. You can see all the groups are eclipsing with each other. So these conversion from what you call Fischer to Saha's is very important. Of course, Newman and wedge is less spoken about, only in rare cases, but these two are considered to be most important when you are pursuing the organic reactions or stereochemistry of a particular compound. Alright, so go through this video, watch it until the end, and please like, share, and subscribe, and keep watching for more videos on JEE and NEET chemistry. That's it.